All right, today we're going to tackle something that I know can look a little intimidating, polynomial long division. But trust me, by the end of this, you're going to see it's just a simple, repeatable pattern. It turns what looks like a complex algebraic mess into a totally manageable process. Okay, let's jump right in. First, I want you to think way, way back, like back to grade school. Remember the basic rhythm of long division, that steady, step-by-step process you use to divide big numbers? Does that ring a bell? Yeah, I know, this looks super simple now, right? But that four-step pattern you see here, divide, multiply, subtract, bring down, that is the exact same engine we're going to use to solve much more complex algebraic problems. The numbers and variables, they're going to change, but the rhythm, that stays the same. Okay, first up, let's do a quick refresher on that core pattern. And here it is. This is the whole engine, right here. Divide, multiply, subtract, bring down. That's it. You just repeat this little dance until the problem is solved. This is the key to everything we're about to do. Okay, so now that we've got that pattern fresh in our heads, let's take it to the next level. We're going to apply it to a polynomial. The playing field looks way different, I get it, but the rules? They haven't changed one bit. And here's the puzzle we're going to solve together today. Dividing x cubed plus 12x squared plus 41x plus 72, all by x plus 8. Yeah, it looks like a lot, but our simple four-step pattern is all we need. All right, let's get into the step-by-step solution. We're going to do this together piece by piece. All right, cycle one, step one. All you do is look at the very first term of each piece. We've got x cubed, and we're dividing it by x. So what's that give us? Yep, x squared. That's the first part of our answer. Simple as that. Okay, now for step two, we take that x squared we just found and multiply it by the entire divisor, the whole x plus 8. That gives us x cubed plus 8x squared. Now, we subtract that from our original polynomial. The x cubed terms, they cancel out, gone. And 12x squared minus 8x squared leaves us with 4x squared. Boom. And to finish up this first cycle, we just bring down the next term. That plus 41x just drops right down next to our 4x squared. And just like that, look at that, we're all set up for round two. See that pattern starting to show up? And here we go again, right back to the top of the pattern. Divide, we take our new leading term, 4x squared, and divide it by the divisor's leading term, x. And that gives us the second piece of our answer, a positive 4x. You know what comes next, right? We multiply. We take that 4x and multiply it by our divisor, x plus 8. That gets us 4x squared plus 32x. We subtract. The 4x squareds cancel out again, and 41x minus 32x leaves us with 9x. And for the last step of this cycle, we bring down again. The very last term from our dividend, that plus 72, drops down. So now we've got 9x plus 72. We are so close. This sets us up for the grand finale. All right, final cycle. Let's do it. 9x divided by x. That's just 9, right? So we get a positive 9. Now, multiply that 9 by x plus 8. And what do you get? You get 9x plus 72. So check this out. We're subtracting 9x plus 72 from, well, 9x plus 72. And what happens when you subtract something from its identical twin? You get a big ol' 0. That means we have 0 remainder. It divided perfectly. So clean. So there you have it. All we have to do now is gather up the pieces we found in each cycle. We got an x squared, a plus 4x, and a plus 9. Put them all together, and that's our final answer. We did it. We totally conquered that polynomial. Okay, so that's awesome. We solved it. But what if I told you there's a powerful shortcut, a way to find out just the remainder without doing all that division? Well, there is, and that's what we're looking at next. It's called the remainder theorem, and honestly, it's a super cool trick. It basically says if you're dividing a polynomial by something simple like x minus r, you can find the remainder in like 2 seconds. All you have to do is plug that r value right back into the original polynomial. So here's the more official sounding definition, but let's connect it back to our problem, right? We divided by x plus 8. Now you gotta be a little careful. That's the same as x minus negative 8. So our r value is actually negative 8. The theorem says that if we plugged negative 8 into that big, long polynomial we started with, the answer we'd get would be the remainder. And since we know our remainder was 0, that's exactly what would happen. It's an amazing way to double-check your work. All right, let's wrap this up by looking at the toolkit you've just built for yourself. So, what are the big takeaways here? First, and this is the most important one, this isn't some brand new, scary thing. It's the same exact rhythm you already know from basic arithmetic. Second, that four-step pattern is your North Star. Divide, multiply, subtract, bring down. Always. Third, the remainder theorem, that's your secret weapon, a super fast way to check for remainders. And finally, why does any of this even matter? Because this skill is the key to unlocking how to factor and solve much bigger, more complex polynomials later on. It's a foundational skill. Look, you came here to figure out how to divide and conquer a specific kind of math problem. And what you've seen is that even a big, messy challenge can be broken down into simple, repeatable steps. So I'll leave you with this question. Now that you can divide, what else can you conquer?